A very good morning to sir. This is our video presentations for our assignment, Introductions to the Statistical Economics. And here is our group member, Ho Ke-ying and Jing Xuan.
In this question, we need to get the data from the question. So a random sample of 44 UN graduate means that N is equal to 42. And then they work at an average of 5.5 years. So this is a sample means 5.5. And it's also given the sample standard deviation is 1.1 years. And also the degree of confidence is equal to 99%. So we can use the formula sample mean plus minus t times sample standard deviations divided by square root of n. And how to find the t? T we can find for the t value, we need to see the t table. And then from the question, the data given by the questions, we know that our degree of freedom is equal to n minus 1. So 42 minus 1 is equal to 41. And then we look for the column 99%, we will get to know the t is equal to 2.701. And then we put in our formula is equal to 5.5 plus minus 2.71801 times 1.1 divided by square root of 42. So it will be 5.5 plus minus 0.458. So our lower limit is equal to 5.042. And our upper limit is 5.958. So is about 99% of this interval will contain the population mean.
Question 2a asks for difference between null hypothesis and alternative hypothesis. Null hypothesis is a statement about the value of a population parameter developed for the purpose of testing numerical evidence, while alternative hypothesis is a statement that is accepted if the sample data provides sufficient evidence that the null hypothesis is false. What is the difference between a one-tail test and two-tail test? One-tail test is used when the research hypothesis predicts the direction of the effect, either an increase or a decrease, while two-tail tests are used when the research hypothesis does not predict a direction. And one-tail tests also affect in one direction only, but two-tail tests affect in both directions. P-value is a number that helps you determine the strength of evidence against the null hypothesis in a hypothesis test. According to the question, given the mean is 6.6 pounds and 5% level of significance with a sample data which is 9, 7.3, 6, 8.8, 6.8, and 6.6 pounds, make a decision. Step 1. H0 is mu not equal to 6.6, which is mean given in question, and H1 is mu equal to 6.6. Step 2 is alpha equal to 0.05, which is given in question, and we use t-distribution test for this question. Step 4, we reject H0 if computer t more than 2.477, which is critical t refer from t table, and reject H0 if computer t more than negative 2.477. Then we calculate t with formula that sample mean minus mu divided by standard deviation divided by square root n. The sample mean and standard deviation is calculated by the given data. So t equal to 7.56 minus 6.6 divided by 1.18 divided by square root 7. Then get the answer 2.133. Then we draw the bell-shaped graph and make the decision that 2.133 fall outside the rejection region. So H0 is not rejected. We cannot conclude that the average birth weight is different from 6.6 pounds. Question 3a asks to list the 5 steps of hypothesis testing. Step 1. State the null hypothesis and the alternative hypothesis. Then select the level of significance and select the test statistic. Step 4 is formulate the decision rule. Last, make a decision and interpret the result. For B, we want to find whether the mean salary of workers in the fast food industry was greater than restaurant in study, and given the information on the amount earned last week by a sample of workers with 0.1 significant level. Step 1, we state the H0 is mu fast food industry less than equal to mu restaurant industry, and H1 is mu fast food industry more than mu restaurant industry. We use alpha equal to 0.1 and t-distribution test for this question. Step 4, we reject H0 if computer t more than 1.363, which is the critical t refer from t table with df11, which is 6 plus 7 minus 2. Then we use calculator to find sample mean fast food is 142.5, standard deviation is 149.9, and sample mean restaurant is 130.29, and standard deviation is 249.24. Then we write in the standard deviation into formula to find sample values, and then get the answer is 204.09. To calculate t, we use formula that sample mean fast food minus sample mean restaurant divided by square root sample values multiplied by 1 over n fast food plus 1 over n restaurant. So 142.5 minus 130.29 divided by square root 204.09 multiply 1 over 6 plus 1 over 7 and get the answer is 1.536. We draw the bell-shaped graph and make the decision with 1.536 fall inside the rejection area, reject H0. We can conclude that the mean salary are greater for the fast food worker than the restaurant worker. We also know that the p-value is between 5% to 10%. You can see in the table.
For questions 4A, in these questions, we need to find the keywords of the questions. Investigate of the effectiveness of an training program is to improve the customer relations, include a pre-training and post-training customer survey. To compare the difference, they compute different. The worst difference is the keywords. We need to find the difference between the post-trainings and the pre-training survey. The keyword difference means that this is a dependent sample. So for our step 1, we will state our new and alternate hypothesis. So our HO is mu difference smaller or equal to 0, and our alternate hypothesis H1 is mu difference greater than 0. We want to see is any different or improving compared in the post and pre-survey. So for our step 2 is state our level of significance, which have given by the questions. Alpha is equal to 0.05. And for step 3, we will use T distribution test to solve these questions. For step 4, we need to formulate a decisions rule, which is reject HO, the new hypothesis, if calculated T is greater than the critical T. To find our critical T, we need to find the degree of freedom. So we will build our difference table, which is the post minus the pre-survey. Our data will be 2003216. So from this data, we get to know that the mean of difference is equal to 2, the standard deviation is equal to 2.082, and our number of the data is 7. So we can find that the critical T first. To find the critical T, we need to look at the T table, which is the degree of freedom and also the alpha. So our degree of freedom is equal to n minus 1. So 7 minus 1 is equal to 6, and our alpha is equal to 0.05. So it will be 1.943 for our critical T. For our calculated T, we will use all our data to put in our formula, which is the mean difference divided by the standard deviations of difference divided by the square root of n. So 2 divided by 2.082 divided by the square root of 7 will be 2.542. So our calculated T is greater than the critical T. For the step 5, we will make our decisions. And then 2.542 is fall inside the rejections region, which is shown by the bell-shaped graph. And then we decide to reject the HO. We can conclude that the training was effective in improving customer relations. So for the questions 4B, we need to complete the partial ANOVA table. The first we will move on to the column degree of freedoms, which is given to data right. So we use the 11 minus 2 equal to 9. So our degree of freedom for error is equal to 9. And then we move on to the column of sum of square. And then we already get the degree of freedom for the error, and then we have the mean of square. The sums of square divide the degree of freedom is equal to mean of square. So we can find the sums of square for the error by multiple the 20 and 9. So 20 times 9 is equal to 180. So the sums of square for error is equal to 180. And then we can find the sums of square for the treatments. It will be 500 minus 180. It will be 320. And then we already have the data for our mean square for the treatment. So 320 divided by 2 is equal to 160. So for the statistic F will be 160 divided by 20. So it will be 8. So we continue to answer the following questions using the 0.05 significance level. For air, how many treatments are there? There are 3 treatments, which is 2 plus 1 is equal to the degree of numerator plus 1. And for B, what is total sample standard deviation? Sample size. The total sample size is 12, which is 9 plus the treatment, because the degree of freedom for the denominator is n minus k. So we use the degree of freedoms plus the k is equal to 12. And what is the critical value for F? Critical value, we use the degree of numerator and the degree of denominator, and alpha is equal to 0.05, right? So we get to know with our critical F if is equal to 4.26. And for D, write out the null and alternate hypothesis. Our HO is mu1 equal to mu2 and equal to mu3. And our H1, which is the alternate hypothesis, will be not all treatments mean are equal. So for E, what is your conclusions? For my conclusion is we need to we need to formulate the decision rules first. So it will be reject HO if calculated F greater than our critical F 4.26. So 8 is greater than 4.26 and F is fall inside the rejection error, reject HO, and we can conclude that not all the means are equal. This is the questions for 4C, and from these questions we get to know there are 3 treatments, and we it's given that the significance level is equal to 0.05. We want to check if there any difference in the mean flight times among the 3 airlines. For our first step, we will state our new and alternate hypothesis, which is HO is mu1 equal to mu2 equal to mu3, and H1 is not all the treatments mean are equal. For step 2, our significance level already stated at the question, which is alpha is equal to 0.05. For step 3, we will use S distribution test for these questions. For step 4, we need to formulate our decision rule, which is reject HO, the new hypothesis, if calculated F greater than the critical F. To find the critical F, we need to determine the degree of freedom of the denominator and numerator. So the numerator is equal to k minus 1, which is 3 minus 1 is equal to 2, and the denominator is equal to n minus k. N is referred to all the data that in 3 treatments, which is 35 minus 3, so it equal to 22. And then the alpha is equal to 0.05, so our critical F will be 3.32 because there is no denominator for 32, so we use the degree of freedom of denominator of 30, so it will be 3.22. And then the calculator F is I will make a table for all the three treatments, which is a pink table in the the right hand side. So it will be the sums of x for each treatment and also the total treatment. And I will use this data to calculate the sums of square for the total and the treatment. And for the SST, which is the sums of square of total, it will be the sums of sums x squared minus sums of sums x squared divided by n. So it will be 796.9971. And then for the sums of square for the treatments, it will be sums of x for each treatment and minus the sums of sums x for the all treatments and divided by each number of treatments, each data. And then it will be 127.114 for the sums of square for the treatment. So the sums of square for the area is equal to the total minus treatment. It will be 669.857. And then the degree of freedom already find while the we find the critical F. It will be 2 and 32. And then the mean square will be the sums of squares divided by the degree of freedoms, which is for the treatment is 127.114 divided by 2 is equal to 63.557. And then for the error is 669.857 divided by 22 is equal to 20.933. And then to get our statistics F is equal to the mean square of treatment divided by its mean square of error. So it will be 3.04. And then our calculated F 3.04 is less than the critical F, which is 3.32. So 3.04 is fall outside the rejection error. So we do not reject the new hypothesis HO, and then we cannot conclude that the means are not all equal. Thank you.